we spent some time going through the new kind of ones, the hyperbolas, and we said a good way to identify them is the minus sign. The ellipse has a plus sign. The circle has a plus sign, but the hyperbola has a minus sign. And another thing we noticed is that A and B stay stationary, but X and Y will change. And it is the term that comes first where your transverse axis is, because in subtraction it matters which one is first. We call it a transverse axis because that's where your parabolas, or little hyperbola things, go off of that axis. So we kind of got a little bit, we did a basic one, and today we're going to take one where we complete the square and we do the whole thing. So we're going to start with this guy. So if you kind of write this down, we'll work from here. We also found that your c squared formula is really like Pythagoras formula. C squared equals a squared plus b squared. Because your both side points fall outside of your box. We use that little box. Alright, so we notice we have two squares. We notice one is positive, one is negative. It tells us hyperbola. So we're going to group together your x's. We're going to group these guys together. And we're going to group together your y's. Oops, sorry. No other y there, right? No other y. And we're going to move this guy, there's no y there, sorry. And we're going to move this guy to that side. Okay? Negative 16, yes, thank you. And now we're going to complete the square, if we have to complete a square. If there is nothing here, then what is the y value for the k value for your vertex? 0. Yeah, it's like the x squared, y squared thing. Now we notice this guy here. We have to complete this. But before we can do that, this has to be a 1. We have to factor this out. So we take out a 4, and we're left with x squared plus 2x plus something. And we're going to add it to the other side as well. Now, inside your parentheses, what's half of 2? 1. What's 1 squared? 1. But now remember, you're going to distribute to get this out of there. So we're going to move this. So 4 times 1 is 4. Okay. Minus 3y squared, bring this 4 down, equals negative 12. Now we need your hyperbola to be equal to 1. So what do we divide by? Negative 12. Now watch what happens when we divide by a negative 12. This first term is going to become the negative, right? So I'm going to swap it to this side of the equal sign. 4 goes into 12 3 times. So x plus 1 squared over 3. I'm just moving that out to that side. That would be the negative part of it. Right? Isn't a positive divided by a negative a negative? So I move the subtract here. Isn't a negative divided by a negative a positive? So this guy is going to be a 4. Do you see what I did? No? Okay. Because watch. This one first, let me leave him in place. This one would come out like this. Watch. If I left it in place and I did a positive divided by a negative, I get a negative. Bless you. A negative divided by a negative, I get a positive. Now, could this be an ellipse as it is? No. Why? There's a plus, but this guy's negative. They both have to be positive. So therefore, I have a hyperbola. But my hyperbola has to be positive minus positive. So I got to switch this guy around. Does it matter where I put this negative sign? No. Come on, guys. Minus x plus 1 squared over 3. So there, this is how we end up with our hyperbola. Okay. What's the center of this hyperbola? -1, 0. Okay.
But how you get -1?
Take it out the opposite way. Okay, I'm going to get rid of this one. More room. Yes.
So if the negative sign was in front of that, you wouldn't move the equation around?
I did. I moved the equation around.
No, if it wasn't
No, I would leave it the way it is. Yes. So, my center is at -1, 0. Which one's my A, the 4 or the 3?
4.
So there's my A squared, there's my B squared. So what's A? 2. What's B? Radical 3. And how do I find C? C squared equals A squared plus B squared. It's like Pythagorean theorem. You got A and B. 4 plus 3. So C is equal to radical 7. Well, no, this is the hyperbola. The hyperbola one changes. The ellipse one is minus. The hyperbola one is plus. And you'll see as soon as we do this, it has to come outside of that. So that's why we add it. Now, our transverse axis is which axis? The X or the Y? Which one comes first? The Y. So it's going to go off the Y. It's going to come up like this and down like this. So let's start with your center. So your center was -1, 0. This is my translated center. I'm just going to make a little axis there so we can work off that. Now off your Y, we're going up 1. We're going up 2, down 2. So therefore, this is where your vertex is. So what's your vertice points? The Y comes first. Whichever term is first is your major axis. It's 2. These 2.
Oh, okay.
Sorry. 2. Up 2. I was at the -1, 0. Sorry. So we're going up 2, down 2. So what's my vertex point at? -1, 2, and -1, -2. My parabolas are going to go like this. So now, we don't have covertice, but we need the concept of a covertice to make our rectangle. So we go left and right, B units, which is radical 3, which is a little bit more than 1, like a little less than 2. So out here. So let's make, my board's a little bit off. So let's make, we don't really need these points, but we need to get this rectangle here. And we need to, this is really off. Sorry, this is really off. Let me see if I can do this. Sorry. Where's my thing? Okay, a little bit better. Okay, there's my vertex. Now, I need to make my rectangle, and I need to send my diagonals through my rectangle. Send your diagonals through. What are these diagonals called?
No.
Look at your notes from yesterday. What are the diagonals called?
Transversal. No.
Foci.
The major axis? I don't know what the whole
Asymptotes. I thought I was going to be on my second cup of coffee already.
Oh,
Waiting for this answer.
okay.
They're asymptotes. They're the guidelines to help me build my parabolas here. So now, off of my vertex, I use this as my guideline. Your translated y-axis is your transversal because that's where your hyperbola transverses off of. Okay? So there's my hyperbola. Now, we know your vertices, we know your center. Your foci sit inside your little parabolas. So your foci is here, and your foci is here, which is why, Rachel, we add them together. It puts us outside of it. We subtract them to stay inside our ellipse, but we add them to be outside of it. So now, off of the negative 1, 0 center, I'm going to go up and down radical 7. I'm changing the y. So my foci are going to be at negative 1 plus or minus radical 7. I can just leave it like that. There's nothing I can do to that.
How do you know it's going vertical?
How do I know it moves vertical? My foci has to be inside of here.
That's how you know.
So your vertices and your foci stay on your major axis. Your major axis is the guy that comes first. We call it a transverse axis in this, because that's where they transverse off of. You technically only have one axis. That's why we don't say major, because there's no minor.
Also, you got the axis first and the equation
And it's horizontal. And so the reason we don't say major and minor is because we technically don't use your covertex. We only use it to make your box. So we technically don't have a minor axis. We only have one. So therefore we call this guy your transversal axis versus a major. If you want to call it a major axis, that's fine with me. That's fine too. Now, we need the equations, yes.
You have to label that every time you graph it?
No, not at all. Now, we need the equations of your line to go through here. The asymptotes, the two asymptotes. Now, your equations were this. Guys, I seriously need your attention. Yesterday it was simple because we were at the 0, 0. We counted your slope. We moved it over. Now, I just want you to watch up here. Watch me do it, and then we'll do it again together. We determined yesterday that your square root of your y denominator and the square root of your x denominator gave you the slope. So y over x, your slope is change in y over change in x. So here's my y. So square root of 4 is 2. Square root of 3 is just radical 3. This is my slope. That's the slope of that line. Now, we can't just use y equals mx plus b because b is not 0. I didn't cross the y-axis at 0 this time. So watch how nice this actually works. Do you see where it says y minus k? Come down to your y, and we really don't have a y minus k, right? It's y minus 0. Get rid of the square. So technically it would say this, y minus 0 squared. You want what's in here. So y minus 0 is the same as y. Plus or minus, there's your slope. And you want what's in this x guy right here. You don't want the square because we don't have a square when we make a line. But we want the x plus 1. There's your equation of your asymptote. It was nice yesterday when we went through the 0, 0. We calculated your slope. We had no intercept. We said y equals plus or minus your slope. We're not crossing at the 0, 0. But what I want you to realize is this lines up to your equation. We don't put any squares in there because the line doesn't have a square, an x squared or a y squared. So we get your y minus k from down here. Y minus 0. Y minus 0 is the same as y. So we put the y here. We get this guy from x minus h. We come down here and we say x minus h. This is the x plus 1. Now, should this have been plus 1, we just have to, are you okay with that part first? Everybody see where we got your asymptotes from? Now, for instance, if it said this, and this was what was in my y, all you would have to do is get rid of this 1, subtract it to the other side, and it would be y equals negative 1 plus or minus, and you can absolutely leave it like this. You can leave it like that. You don't have to distribute anything. You can leave your equation that way. You see what I'm saying here? Kinda? Sorta? You could even check this guy in your calculator. You could put it in with the plus, you could put it in with the minus, and you can see if it intersects at negative 1, 0. And there's your asymptote. It's very hard to put your hyperbola on here without taking your square roots of everything. But it's okay to put your asymptotes there and see that they cross at your center. Okay? You see what I'm saying about this asymptote line? We can line it up to that equation. When we're at the 0, 0, we had no trouble. But we got a little bit more of a problem with that one. Alright, so the first one on your homework, how do I know that this is a hyperbola? The minus. It only has one minus. So I know it's a hyperbola. Which one is your transversal axis? The x, because it comes first. In a subtract, it matters who comes first. So I've got a hyperbola, and it's going to go off my x-axis. That's where we say transverse. Okay? Now, this is my a squared. This is my b squared. That doesn't change. So what's the center of your hyperbola? 1, negative 2. What's a? What's b? And let's find c. Now remember, as soon as you do this, this is like Pythagoreans. 4 plus 1 equals c squared. So c is radical 5. Okay? So let's draw what we know. Everybody work with me here. Get your center. 1, negative 2. Let's draw a translated axis with this center. Your center is at 1, negative 2. Your transverse axis is your major axis. It's the only one we're going to work with. It's going 2 to the left and 2 to the right. Agree? I'm off of here. Here I am. Square root of 4 is 2. I'm going to go 2 to the right. I'm only over here 1, so I'm going to go 2 and 2. These are my vertex points. So, give me the points for your vertex. 3, negative 2. And negative 1, negative 2. Everybody okay with the negative 1? All right. Now, technically, we don't have a co-vertex, but we have to draw. We have to kind of map it out. So we're going to go up 1 and down 1. I don't really need to know those, but I just need to draw this. So now I draw my rectangle. Sometimes it's nice to write this going up 1 and we went over 1. That'll help you get your slope. Went over 2, it went up 1. Draw your diagonals through here. Diagonals like this. These are called what? Asymptotes. Good. These are my guidelines. So I draw my hyperbola through my vertex. I don't let it touch my rectangle or my asymptotes. I use this as my guideline. Same thing here. I use it as my guideline. That's my hyperbola. Now your foci sit on your transverse axis, which is your x. Just like a parabola, it sits inside of it like this. And it sits inside of this guy. So give me your points for your foci. I want the points for your foci. It's moving across your x translated axis, which means my x value has to change. How many units is it changing? Radical 5. So I need to say 1 plus or minus radical 5 negative 2. 1 moved 1 plus radical 5, 1 moved 1 minus radical 5. But I need to leave it exactly, so I'm just to leave it like that with my radical 5 in there. Now, all I have to do is find the equations of my asymptotes. Now watch. Here's your equation again. Let's fill these pieces in. See your y plus 2? You don't want the square. You just want this to say y plus 2. See your x minus 1? You don't want the square, but you want this guy to say x minus 1. Plus or minus. This is your slope. Okay? The slope goes up and over. So here's your line. Up 1 over 2. Square root of your y denominator, 1. Square root of your x denominator, 2. See your slope? Up 1 over 2. Up 1 over 2. There's your equation of your lines. Now, all I need to do is get y by itself. So subtract 2 from both sides. Y is equal to, and just write it just like this. And I don't have to distribute anything. I just have to leave it like that. So we're still using your y equals mx plus b, but because we translated your center, it's whatever we translated it from. Y minus 1, y plus 2, x minus 1, x minus 5. Whatever we did, we're still really using your y equals mx plus b. We're using your slope, square root of the denominator of the y, square root of the denominator of the x. This is slope, changing y over changing x. Okay? So now we know all your pieces for your hyperbola. Center, vertex, it has no co-vertex. We just use that to make our box, our rectangle. Equations for your asymptotes. Your foci points outside of your box. That's why we say c squared equals a squared plus b squared. Did you confirm that on your phone, Daniel? You confirmed it for us? Good. Daniel confirmed it. He phoned a friend. Okay, so any questions? All right, you have this time. Work on your homework.